Okay, so for this one, we're going to look at accuracy. And accuracy is how close your reading is to the true value. How do you find the true value? Well, it might be a universally accepted value, in which case you can use a book of data like the enthalpy change of butane. It might be on the packet for your substance. If you're measuring vitamin C, it might well tell you how much vitamin C is meant to be in there. It might be something you can look up. So if you're looking for vitamin C in tomatoes, you can find nutritional details on this. It may be a little hard to find true value if you're doing something original, but if you can find somebody else's experiment that is even close to yours, you might at least be able to compare some level of accuracy with that. How do you calculate accuracy? Well, it's percentage error, which is the difference between your value and the true value, divided by the true value times 100. So if, for instance, you got 50 grams and the true value is 55 grams, well, the difference between these two is 5. You're going to divide that by 55 because that's the true value times 100. Now, what accuracy tells you is about the size of your systematic errors. So systematic errors are things that are always going to affect your results in the same direction. They're always going to make them too large, or your results too large, or always too small. If you identify a systematic error, you should always tell us which way it's going to affect your results. So examples might be a zero error. If your equipment's not properly calibrated, that will also give you a systematic error, and zero errors are a type of calibration error. Other factors might be if you're transferring and you're leaving liquids behind and it's a significant amount, that will always affect your results in the same direction. Heat loss, you're always losing heat, you're never gaining heat if you're doing an exothermic reaction. So all of those are systematic errors. Another way you can judge it is if you have a graph and you were predicted to go through a particular point, go through 0, and instead you end up with a plot like this. And you need to be able to justify that you'd predict to go through 0, wherever your intercept is. And then the difference between your line and the gradient of your line, or in this case, it would be the difference between the intercepts you would use in order to calculate your percentage error. Or you can also, at times, if you have a difference in the predicted gradient, you can use that to calculate your use your equation for your line of best fit and your value for M and see how that varies, and use that to calculate percentage error.